Hi, welcome. In the previous lesson, we looked at physical properties, and when we were looking at physical properties, we saw that physical properties basically involve the changes which are basically visible, like solubility, viscosity, frequency, boiling point, ductile, how you can coil metals into into round shapes, and malleable, the ability to shape a metal in the way you like. All these properties describe the physical characteristics of a substance and not how substances behave chemically. In this instance, if you have ductile, it means here when we are looking at boiling point, we are looking at what temperature does a substance boil. If we are looking at malleability, we are looking at the fact that you can roll this compound this element into different shapes, and ductility, it can make wires. Here you can also look at frequency and viscosity, how the liquid flows. All these are but physical properties that you are looking at. All these are just but physical properties that you are looking at. So today we are going to look at chemical properties. Today we will look at chemical change, and when we are looking at chemical change, in physical change, as you can see here, when you boil water, this is just but an example of a physical change. So when the water boils, what happens is that it is just changing state, and it does not change its chemical composition. So let's embark on what we are here for today: chemical properties and chemical change. Chemical properties and chemical change. So when we are looking at chemical properties and chemical change, what are we looking at here? So when we are looking at chemical properties, a chemical property relates to a substance's ability to undergo changes, a chemical change, a chemical change or chemical property, not chemical change, a chemical property relates to a substance's ability, a substance's ability to undergo changes, that transform it into different substances, So as we saw in earlier video, we saw that when you take iron and you mix it with, of course, sulfur, and you produce iron sulfide, that will be a chemical change, because even the properties of the two substances will not remain the same, but rather they will change. So chemical properties are easier to see when substances react to form new substances. Chemical properties are easier to see when substances react to form new substances. So when substances react to form new substances, then this is directly a chemical property. So if you take carbon, for example, then you burn it in air, that is in oxygen, of course, will react with it. You burn it in air, that is, it will react with oxygen, and the byproduct will be carbon dioxide gas. So you can see that here we have carbon, a solid, reacting with a gas, and we end up with a gas which is carbon dioxide. So after the chemical change, the amount of the original substance in carbon and oxygen are not less than before. So chemical change does not reduce the amount of substances in a substance. So we say, let's try and go to another page here. We are saying here that after the chemical change, the amounts of the original substance, the amounts of the original substance carbon and oxygen, are not less than before. Maybe we will take just a simple example to try and make things clear here. You have magnesium metal, which is a solid, plus oxygen, which is a gas. Then they react to form magnesium oxide. You will see that the number of oxygen in this is a solid, magnesium oxide, and the number of this will still remain the same. So this is just but an example. We have many examples that we could show here. So a change in which one or more substances are converted into different substance is called a chemical change. A change in which one or more substances are converted into different substances, into different substances is called a chemical change. It's called a chemical change or chemical reaction or chemical reaction. So the substances that react in a chemical change are called the reactants. The substances that react are called the reactants. The substances that react are called reactants. The substances that are formed by a chemical change are called products. The substances that are formed by a chemical reaction or chemical change are called the products. So if we are looking at the example here, these are the reactants. That is the oxygen and the magnesium, and this is the product. So matter can be pure or a mixture. Matter can be pure or a mixture. So what we mean here is that matter exists in an enormous variety of forms. So any shape of matter, however, can be classified either as a pure substance or a mixture. So any sample of matter can be classified as a pure substance or a mixture. So any sample of matter can be classified as a pure substance, or a mixture. So the composition of a pure substance is the same throughout and does not vary from sample to sample. The composition of a pure substance is the same. It's the same throughout. It's the same throughout and does not vary from sample to sample. Does not vary from sample to sample. A pure substance can be an element or a compound. A pure substance can be an element or a compound. Can be an element or a compound. So when we are looking at carbon dioxide, it is a pure substance. When we look at water, it is a pure substance. And when we look at other examples, they are pure substances. They are pure substances. A mixture, in contrast, a mixture, in contrast, contains more than one substance, contains more than one substance. They can vary in composition. They can vary in composition. And properties. And properties from sample to sample. From sample to sample. And from some time from one part of a sample to another part of a sample. And sometime from one part of a sample to another part of a sample. So we can take an example where when we are looking at the composition of air, air might be composed of nitrogen, oxygen, carbon dioxide, neon, and so forth. So all of them, make a mixture. So from a mixture, we can get a pure substance. We could get nitrogen as a pure substance. We could get oxygen as a pure substance, and so forth. So let's go to the video and some structures here so that it's easy for us to understand. So we already looked at physical properties. Now let's go ahead and look at chemical properties. So properties of a substance that describes how that substance's chemical composition will change given a specific set of conditions is called a chemical property. Like if something is flammable, it means it can burn and change its property. Radioactive materials can react with other compounds to change their properties. Corrosive means that if you have acid and metal and you put them together, they might react and form new substances. When in combustion, for example, you burn paper, you will get ash and you will not be able to get the paper back, and so forth. All these are chemical reactions, explosive, something being toxic or hydrophobic. So if we just look at example here, freezing point, when we look at freezing point, what will it be? Chemical or physical property? Freezing point. So when we are looking at physical point, it will be a physical property. When we are looking at combustive or combustion, it will be a chemical property. When we look at water reactivity or how water reacts with a certain chemical, it will be a chemical property. When we look at other substances, so here this is chemical property. Viscous material gives you a physical property. So here we are talking of viscosity, how thick a substance is, so or how thin. Toxic, it is chemical. So if toxicity brings about a chemical change. Condensation point is physical property. Condensation is a physical property here. Then pyrophobic, this is chemical. Corrosive is chemical. Melting point is physical change. So from here we will go to a table so that we try to iron a few points out. So clearly from the table that we have here, we are going to see classification of matter. This classification scheme for matter shows the relationship among mixtures, compounds, and elements. So here we have matter, and matter can either be separated. So if it can be separated, then you know that is a mixture. If you can't separate it, then it is a pure substance. If you can't separate it, it's a pure substance. Then when you look at the mixture, is the composition uniform? Is the composition uniform? If the composition is uniform, then we refer to it as being homogeneous mixture, like if we take sugar in water, or stainless steel, or air. Or it may be, if it's not uniform, then it is heterogeneous mixture, and a heterogeneous mixture like the one of blood and wood and graphite. Then here on this side, the substance is pure, yes. If it is pure, can it decomposed by ordinary chemical means. If it can be decomposed by ordinary chemical means, then it will form a compound. That will be a compound. So if you are having, for example, let's just take but an example, maybe here we are looking at a compound like sodium chloride. So if you are able to break it down into its constituents and you end up with sodium as a metal and chlorine gas, then that is a compound. So if you are having a molecule of oxygen and you break it down, what will happen? You will have two oxygens. They are both oxygens, so that is an element. So an element will have the same types of atoms, but a compound will have different types of atoms. We will stop here, and in the next unit we will look at the differences in mixtures, or how we can separate their mixtures.